Hello guys, welcome to Learn with Winky. Today I want to show structure analysis of bracket without a stiffener and with a stiffener. So the aim of this video is to get to know like how the simulations uh, changing the designs, like how we can apply these simulations in our real world problems and how we can improve our designs. So for this I took two models. One is a bracket without a stiffener and with a stiffener, and I will show the results like stresses and deformation, and we will compare this. So let's move on to ANSYS Workbench. Then drag static structure here. Then the engineering data is same because I want to give same material for both. Only one thing, if I am a stiffener, will be add in the middle of the bracket. Then right click here, geometry, import geometry. I have already modeled the bracket. It should be IGS. Then bracket without a stiffener. First I will see the results and I will see bracket with the stiffener. So double click on model. Here our 3D model has been updated. I can see this. This is without a stiffener bracket. So I will give constraints and boundary conditions to this, and I will see the deformation and stresses of this. And again, I will give the same constraints and same forces, and I will see the results. I will compare the two. So now go to analysis settings, insert, fixed support. Here I will select these two folds. Select this one and as well as by pressing Ctrl these two. Then okay, these two are now fixed. Then I will apply force at here at this location. Another setting, insert, force, force. Sometimes some brackets may fall under load by this entire face, but majorly the small brackets were used to join with other bolts at here. So I will apply load at these two faces, which is downward direction. Here we need to change vector to components, and this should be Z because this is Z direction. Z. So you can see the force has been applied here in downward direction. So now we will give the results what we want. Stress 1 measures, and then insert deformation total. So I will click on solution and solve. So our results are ready. So you can see this bracket deforming like this. The stress would be 118 megapascal, and the deformation would be 0.6. So remember these values. We will see exactly the same analysis, a bracket with a stiffener. Now, so remember the displacement is 0.6 and the stress is around 118. So now we'll close this window. So I will take another static structural, but here I will use geometry which I created earlier, the bracket with stiffener. So now double click on model. Yeah, now our model has been updated. You can see the stiffener at middle, which is around 5 mm thickness. Now we will see the results. Here I will give the same constraints what I gave for the bracket without stiffener. So go to analysis setting, insert, fixed support. I will select these two faces, apply. Then I will select insert force for these two circles. This one. Torque components in z direction minus 1000 Newton. Then apply. So now you can see the force has been applied. Now we need to give the solution here. Insert deformation, then insert stress one meshes, and click on solve. So here I am not touching anything meshing because earlier it has taken default. Now also I will leave to default only. The only aim is to show the difference with the stiffener and without a stiffener. So you can see the total deformation is 0.1. Earlier it was 0.6. Now it was 0.1, which is maybe 5 times, 4 times lesser than bracket without stiffener, and the stress would be 93.865, and earlier it was 118, which is around 10 to 20% lesser than bracket with a stiffener. Maybe stress won't be considered because here the most stress will be at this point. This thing we can restrict by adding some extra material at here. The thing is, the remaining portions, the stresses are very less compared to the previous model. So this is the advantage of adding the stiffener between a bracket or anything where we apply load. That's all for today. Please do subscribe, like. Thank you.